comes to mind when you think of artificial intelligence? Is it robots, self-driving cars, or maybe security technology? There's no single consensus on what AI is, but one definition is that AI is a sentient machine that thinks and behaves like a human.
Jarvis, you there?
At your service, sir.
Gauge heads-up display.
Check.
4-door preferences from home interface.
Will do, sir.
Of course, this is something still firmly in the land of sci-fi, but another definition is a machine that performs tasks that would ordinarily require human brainpower to accomplish. And this is something that we've been seeing since the 1950s when the first chess-playing AI programs were written. Today, AI is capable of defeating the world's best players in competitive esports, games that are vastly more complex than chess or Go. In fact, AI is something we now come across every single day. This type of AI is called machine learning. It includes familiar technologies such as predictive texting, facial recognition software, spam filters, and journey predictions. So how does machine learning differ from traditional computer programming? Well, let's take this example. If we wanted a computer to draw a face, with traditional computer programming, we'd have to write detailed instructions covering every single step of the process, and we'd end up with the same picture every single time. With machine learning, a computer can not only learn to draw a face, but the drawing can improve over time. You can even teach machine learning to finish a drawing of a face that you started, although the results aren't always perfect. So how does it work? Well, machine learning uses algorithms to enable the computer to learn from data, perform tasks, and improve themselves without being explicitly programmed. Machine learning consists of three parts: the input, the learning algorithm, and the output. The input consists of datasets, the bigger the better, and these can be images, text, audio, video, or measurements. The learning algorithm is the real genius at the heart of machine learning. These are the steps the machine takes to create the output. So let's imagine, for some strange reason, we want to create a model that can make us a cake. The datasets would be the ingredients and tools that we need. The learning algorithm would be the recipe or the steps needed to prepare and bake the cake. And the output would, of course, be the cake. In this case, the output would be a standard cake. But the learning algorithm can be tailored or optimized depending on the desired output. For example, if I wanted a pink cake, I could alter the recipe to include step add food coloring. If I wanted a pretty cake, I could include a step to add sprinkles. With machine learning such a large part of our daily lives, it's worth questioning what the algorithms that we interact with are optimized for. Now let's take a quick look at the types of machine learning. The three main types are supervised, unsupervised, and reinforcement. Most machine learning uses a method called supervised learning. In supervised learning, an AI system is presented with training datasets to learn from that have already been categorized into what we call classes and tagged with the correct label. For example, if we wanted to create a machine learning model to classify fruit, we could train it using existing images of fruit that have been classified by type. Once trained with these datasets, the model will be capable of identifying which of these fruits it is being presented with. Supervised learning models are particularly useful for classification, pattern recognition, and predictive tasks, such as locating Earth-like planets or identifying sick patients. Okay, now let's take a quick look at the other two types of machine learning models. Unsupervised learning is similar to supervised, except in this case the training data has not been classified. Instead, this type of model is given a large dataset and it's designed to look for previously undetected patterns with minimum human supervision. For example, if our fruit classification model was unsupervised, it may end up classifying the fruit by colour or shape rather than type. Unsupervised learning models are used for fast classification of large datasets with minimum human supervision. And finally, there's reinforcement learning. With reinforcement learning, the model essentially learns how to perform a task by making thousands or millions of repeat attempts. And each time it alters the way it carries out the task based on feedback. The model will receive negative feedback when it's unsuccessful and positive feedback when it's successful, with the aim of accruing the most positive feedback. This type of machine learning is the most versatile, and we may come across it in the form of manufacturing machinery, self-driving vehicles, and AI gaming. Machine learning isn't just making our daily lives a little bit easier, it's actually making the world a better place, and has the potential to do much more in the future. For example, using Earth observation satellite data, machine learning is helping to fight climate change, end famine, and aid emergency response. In the commercial sector, machine learning is allowing for self-driving vehicles, which reduce the risk of accidents. And it's helping us to better understand the world around us. We live in an age of big data, with increasingly large and complex datasets coming from all sorts of sources. Big data is making it possible for us to gain new and more complete answers to important scientific questions, if we can keep up with it. And with machine learning, we can. Why not try making your own supervised learning model? Google has made it easy and fun with their fantastic teachable machines. You can use your webcam to create your datasets or import images. Visit the UniverseLab machine learning lesson for ideas and guidance on how to get started, and maybe even try one of our machine learning science projects. Thanks for listening, and we'll see you next time.